Good afternoon, everyone. My name is Jez Humble. I work for ThoughtWorks Studios, and I'm here to talk about continuous delivery. So today has actually been a really interesting day from the point of view of continuous delivery. We've had great talks by Mark and Chris earlier today about how Microsoft does a bunch of this stuff, and that's great for me to see people actually. I mean, this is mainstream for a lot of people, which is very exciting. My personal story with continuous delivery starts when I joined ThoughtWorks in about 2005, and the very first project that I worked on in ThoughtWorks was for a major ISP, the company where you want to go online, or you want to get your granddad online, and you give him a CD and he pops it into his computer, puts in his details, and then he has the internet, this kind of company. And they had a great provisioning system, broadband provisioning system that was written in Perl. But their senior architect went and played golf with someone from WebLogic, and so they decided they needed to move on to WebLogic and build a J2EE system. And so they started building this system, and after a few months they had a really powerful system for managing configuration and no actual software. And at this point they brought ThoughtWorks in to try and help them build this new Java-based system. And it was Java. We were developing on Windows laptops. We were deploying to Solaris boxes, to Sun hardware. But of course, Java is platform independent, so that couldn't possibly go wrong, right? We were somewhat concerned. But of course, this is a large company. You can't just buy hardware. You have to go through procurement. And there was no money in the budget, in fact, for the production hardware, let alone any testing hardware. So we couldn't buy any kit at all. We had to go and scrabble around all over the company to try and find some boxes. And we ended up with 4 E4500 boxes, 8 U Sun boxes, fantastic I/O, tiny little processors. And in fact, we did performance testing for the first time in our production environment, and the results were terrible. And we calculated that each one of these boxes would be outperformed by an iPod. We were deploying our system onto a cluster of iPods. It's fantastic. So we got these boxes finally, and we tried to deploy the software we'd been building onto these boxes. And it took us a team of us. We had a team of people dedicated to building and deploying the software, which is, problem number one, bad smell number one. And it took us 2 weeks to deploy the software, and after we'd finished deploying it, finally, it didn't work at all. So that was embarrassing. And we found a number of serious architectural problems when we were trying to deploy the system. First of all, we would cache data to the file system, and that works great on a Windows laptop. You cache the data to the file system, you read it again, no problem. On a Solaris cluster, doesn't work so well. You write the data to the disk on one node, you try and read it on another node. It's not there because it's a different file system. And so we had to do things like putting an NFS share in place. Anyone used NFS here? Okay. Lucky you. Anyone who's used NFS will know that if NFS is the answer to your problem, you've got a pretty serious problem. It's gnarly. So we found all these problems that were expensive to solve because the architecture was baked in by now. We were 6 months in. It was expensive to solve these problems. Secondly, it took us 2 weeks to deploy the system to a production-like environment. How many testers in the audience? Any testers? Okay, a few of you. Developers? Many developers. Any managers? Okay, a bunch of managers. Okay, anyone who hasn't put their hand up yet? What do you do? I know what you do. This is Doc List. Are you an agile coach still these days? Something like that, yeah. Okay, cool. So testers in the audience, you'll know you don't want to be testing on a Windows laptop. You want to be testing on a production-like environment. So it would take us, every time the developers finished work on a feature, we'd want to get feedback. Had they built something according to the specs? Did it work? And so we'd try and deploy it to the production-like environment for testing. And it took us, several days to do this after the first time we'd done it. And every time we did it, it would change slightly. And we go to the developers and say, we can't deploy it. The developers would say, oh, it's your crappy environments. And we go, no, it's your crappy code. And then they'd say, no, oh, yeah, we changed this part. You might want to change your deployment procedure. And eventually we get a build to the testing environment. And the testers would start working on it, and they'd come up with a big list of bugs and give it back to the developers. This is about a month, 3 to 4 weeks later after the developers had finished writing those features. And you'd look at this big list of bugs. I don't know about you. I can barely remember what I was doing yesterday or last week, let alone 3 weeks ago, 4 weeks ago. And so you get these bugs. Half of them are no longer relevant. The other half, you're trying to reproduce them somehow, and then you're trying to find the person who checked in that code, and they've gone on holiday or quit or something, And so it's very painful to get feedback and then to actually act on the feedback and create a high-quality piece of software. Also, when you want to release to production, this is problematic for that as well. And so our customer was worried about release to production. They hired a separate consultancy whose job it was to put together a release plan, on a big Gantt chart, and it was going to take a whole weekend. And so I was on the London Underground going out of town to West London on a Friday night. Lots of people going into London on Friday night to enjoy themselves. I was going to a data centre. And we had to deploy this software. But fortunately, by this point, we had somewhat solved the deployment problem. And the way we did it is we automated the hell out of it. Now, there was already an automated script for building and deploying the software. It was 8,000 lines of Ant, built by the developers. And we went to the operations people and said, hey, how about this? And they said, no, thank you. We don't like Ant, and we're not going to use it. And we said, OK, what would you like to use? And they said, well, we like Bash. And so we said, OK, we'll build you a deployment system in Bash. And that's what we did. And we called that system Conan the Deployer. And you would spin up Conan, and you would tell it the tag in CVS you wanted to build off and the name of the environment you wanted to deploy to, and Conan would build the software and deploy it, and it would take about an hour by the time, 2 weeks before going to production, we got it really finely tuned, and it took an hour. And then the actual release took less than a second, and rollback took less than a second as well, using techniques that were described earlier by Chris, which I'll come to a bit later. And so this was great. On release night, there was this big Gantt chart, release weekend actually, of stuff that had to be done. But releasing the new system only took an hour. And apart from one problem which we found pretty quickly and fixed due to a configuration mismatch between prod and our testing environments, everything went very smoothly. And the best thing of all was nobody ever had to come in at the weekend again to do a release. From then on, we used Conan every time we wanted to make a release, and the deployment team could come in and do the release at 2 o'clock in the afternoon or 10 o'clock in the morning. And it got to the stage pretty quickly where they'd start the release process and go out to lunch and then come back. And it was a non-event. It was boring. And that was fantastic. When releasing new versions of your system is boring, you've won. That's the point of this. And so continuous delivery is about the fact that 2005, I thought, well, this is unusual. People can't be doing this all the time. And then going to lots of other organisations and my colleagues in ThoughtWorks and everywhere, we see this again and again and again. So it's actually a really severe problem in software development. Who in the audience has experienced something like this? OK, many of you, which is, I guess, why you're here. And so this is a pattern that's actually very common, or anti-pattern, I should say, in software development when you're doing agile adoptions. Because, organisation wants to go agile, so normally agile is inflicted first of all on the engineering team, and the engineering team gets to go agile, and you bring in lots of certified Scrum Masters and give everyone the 2-day agile course, and suddenly they're taking orders standing up rather than sitting down from senior management, and that big list of stuff that you can't possibly ever complete is now prioritised and estimated. So then we're agile. Tick, yay! And so you have this team which is, hopefully, if you've done more than the Scrum 101 Agile, hopefully you have some engineering practices as well. And you're doing these nice iterations where there's analysis and development and testing and showcases all going on within iterations that are hopefully 1 or 2 weeks long, something along those lines, not 8-week iterations that you see in some places. But even when you're doing these iterations, you're not actually releasing software to users at the end of every iteration. Normally what happens is the project gets completed, and then the whole thing gets thrown over the wall to the test organisation, who then go and test it. And in these Gantt charts for projects, it's funny, there's a testing phase, and there's never the phase to fix the bugs you found during the testing phase, which always confused me. It's weird. So hopefully you fix some of those bugs, and then the whole thing gets tossed over the wall again to the operations team, who have to then deploy it to production. And conversations go something like this. You walk up to the place where the operations team are, if you're lucky enough that you can actually go to them. They might be in another country if you're unlucky. And then you say, well, this new system we're going to deploy. And they say, what system's that? Oh, no one's told you about that. Oh, yeah, this thing we're deploying in 2 weeks' time? Oh, yeah, there's some new boxes in the corner of our server farm. Maybe that's for your thing. Oh, yeah, maybe we should have a look at those and get them installed and talk about the deployment process. And so this is very common. And what we find is that a lot of the variability in the software delivery process comes after dev complete. You've got dev complete here, and we're pretty good, reasonably good as project management people at estimating this part of the work. You get stories, and then you estimate the stories, and you come out with nice graphs of when the thing is going to finish, and kind of standard deviation, all this kind of nice statistical analysis. And then for this bit, you add a buffer. Probably take about this long, and it never does, of course. Integration, testing, all this kind of thing. It'll be a few weeks. How could that go wrong? And so much of the variability in pain in delivering software comes after dev complete, between dev complete and release to production. And so, who's experienced that? Integration hell, testing hell, yeah, many of us, right? And the question is, of course, can we do better? This is rubbish. Can we do better? And the answer is yes, we can do better. If you go to code.flickr.com and scroll to the bottom, you can see this nice auto-generated report, and if you do the arithmetic, you can see they're deploying more than 10 times a day, which is a surprising number. And a lot of people have a natural reaction, well, these dudes are a bunch of cowboys, and they're, I was actually doing continuous deployment in the year 2000 by FTPing files from my workstation into production. Is that what these people are doing? Well, no, they are not doing this, thank goodness. And when Yahoo acquired Flickr, Yahoo has a pretty traditional change management process, and they said, well, this is nonsense, and we're not having this. And the guy who is in charge of ops at Flickr, a guy called John Allspore, he said, well, actually, I quite like doing this. Can we carry on? Unfortunately, his immediate superior was kind of interested and said, well, go on, carry on for a while, and we'll see what happens. And John Allspore went and gathered the uptime and stability statistics from Yahoo's major services and from Flickr. And what he discovered is that Flickr had a higher uptime than any of Yahoo's major services. The uptime of Flickr in the year they looked at it was, I think, around 24 minutes downtime the whole year. 4 incidents, average of 6 minutes per incident. And so Flickr was actually doing better than Yahoo. And that's the first message that I want to, the first myth that I want to bust. This idea that throughput, frequency of releases, and stability of production is a zero-sum game. This is not true. Having higher throughput, actually, if you do it right, can increase the stability of production, not decrease it. So that's one reason why you'd want to release more frequently. What are the major reasons why you would care about continuous delivery? Why would we care about releasing more frequently? Well, there's 3 main reasons. Number one, until you've released software to users, you don't know whether it's actually valuable at all. Every time we build something, we have a hypothesis, we have a business idea, and we think, can we make money in this way by this idea? And until you actually ship some software, you don't know whether that hypothesis is in fact true, and it may not be. And this is why having these 2-year, 1-year projects is ridiculous, because it's very expensive to spend a year or 2 years to build something that nobody wants. It's much, much cheaper to spend 3 months building something that no one wants, and then getting feedback and iterating rapidly to produce something that actually people do want. Obviously Microsoft started out building basic interpreters, and they found out the money was in operating systems and productivity software. So, but by rapidly iterating, and Microsoft actually, right at the beginning, were doing some really exciting things in terms of automated testing, continuous integration. The first, a bunch of you probably know this already, but the first versions of BASIC that Microsoft produced, the CPUs weren't even in production yet, and they produced simulations of the CPUs based on specifications from the manufacturer and created the basic interpreters and tested them on these simulations. And then when the CPUs were actually manufactured, they had working software, and in one case it actually just worked just like that on the new CPU, which is pretty impressive. So, using these kinds of techniques, you can get fast feedback and find out if your idea is actually going to be valuable. Any time we're building strategic software which is going to make a difference to our business, and not all of your software is like that, but the key projects, the ones that are going to make money for your business, is about innovation. That's what we're trying to do. We're doing innovation, and innovation is risky. Obviously, because you have to have risk to get reward. And so one of my favourite quotes about innovation, unfortunately, here we are at Microsoft, and I have to put Steve Jobs on the screen. Sorry about that. Unfortunately, he was the person who said this. The late, great Steve Jobs says this about innovation. And Henry Ford has a similar quote. He says, if I'd asked my customers what they wanted, they would have said faster horses. So, seems like magic, right? How do these brilliant minds come up with these crazy innovative ideas? They're geniuses, and unfortunately, neither of these people are around anymore. How do we harness the secret of their success? Well, guess what? Innovation, like many other things, is subject to the scientific method, and it works like this: you have a hypothesis, a business idea, and you create an experiment to test that hypothesis. And based on the feedback from that experiment, you work out what to try next, what experiment to run next. This is just the scientific method. And the experiment is the minimum viable product. This is a concept which is popularized most recently by a guy called Eric Ries, who wrote what, in my mind, is one of the most brilliant books of this year. The Lean Startup came out 2 months ago. I highly recommend you read that book if you haven't already. Fantastic book. And the minimum viable product is the smallest amount of software you can possibly write in order to test your hypothesis. And that's what you want to build. You want to think, not what features can I add in to make this successful, but what features can I take out so that I can deliver the minimum viable products and get feedback in the shortest possible time available, so that you spend the minimum amount of money to test your hypothesis. And that amount of money may be almost nothing. There's a great story from the early days of IBM when they invented the computer and they didn't know what to do with it apart from calculate very, very fast. And someone came up with the idea of creating a transcription machine. We're going to give executives the ability to fire all their secretaries, and we're going to have a transcription machine. And they tested this without writing a single line of software. What they did is they got someone in a room with a loudspeaker and a terminal, and someone in another room with a screen and a microphone. And this executive went in to test the new system and said, well, what am I supposed to do? Writing a letter? Okay. So who am I writing letters to? No, don't type yet. No, stop typing. No, don't type. Stop typing. Stop typing. And they quickly discovered this was not going to work at all. And, here we are in 2011, and we've just got Siri, and isn't that exciting, So this was an idea that was never going to work. And they discovered this very, very quickly without doing a 2-year project to try and develop some software for this. So the minimum viable products may be much smaller than you think. And, who works for an organization of more than 1,000 people? Okay, about half of you. How many people have experienced, getting a massive requirements document and they must go into a 2-year project to complete this massive set of requirements, right? Yeah. If you're doing something innovative and strategic, you're dead in the water by that point. The developers need to talk to the business before they write the requirements documents so that they can work out what the minimum viable product is, so they don't waste a load of money on building something useless. And, we're quite good at measuring, do projects come in on time, on budget, on scope? That number is pretty woeful. If you measure the amount of stuff that's actually used, I'll come to that in a minute, it's even more woeful. So we want to get feedback quickly and optimize our delivery process, crucially, for time around this cycle. The second reason to release more frequently is that counterintuitively, releasing more frequently reduces the risk of any individual release. And there's 3 reasons for that, I guess. Firstly, if you release every 3 months and it goes horribly wrong, your natural reaction is, well, that was horrible, let's not do that again for a while, right? That's the wrong thing to do. If something is painful, if it hurts, the right thing to do is to do it more often and do it from as early on as possible. If it hurts, do it more often and bring the pain forward. So if your deployment process hurts, do it more often. And what happens when you do it more often? Well, firstly, the batch size, the amount of stuff you're releasing, becomes much, much smaller. And when that happens, it means that if something goes wrong, it's much easier to find out what went wrong. Well, it was these few lines of code that we changed. If you're releasing changes 10 times a day, it's really easy to work out what went wrong. What changed since last time? Oh, it was these 2 lines of code. Or this Apache configuration, IIS configuration setting, or these schema changes we made to the database. It's very easy to do root cause discovery. And this is how Flickr got that really low time to restore service. It's because time to restore service, there's 2 parts to it. The first bit is where you find out what the problem was, and the second bit is where you restore the service and fix the problem. And what Flickr did is they eliminated that period where you're trying to find out what the problem is, because it's really obvious what the problem is. It's these 3 lines of code, or this change we made since the last time we released an hour ago. Second, it's much easier to then fix those problems because rolling back a few minutes or hours worth of changes or even days worth of changes is much easier than rolling back 3 months worth of changes. And finally, the third reason is you get to practice the deployment process many, many times and you get very good at it. So that's why releasing more frequently, if you do it right, actually reduces the risk of any individual release. The third reason to release more frequently is because it's the only real way to measure the progress of how you're doing with your software delivery. You know, we've got all these methodologies like earned value and these complex statistical mechanisms to give us really fine-tuned numbers on when we're going to deliver stuff. There's a word I use for this complex mathematical process. I call it guessing. And we're quite good at guessing. You know, our intuition is quite good. But the longer the project is, the more likely we are to be horribly wrong. And that's because, as we saw earlier, most of the pain and variability comes between dev complete and released. And that really comes down to our definition of done. You know, you go to developer and you say, you're done with that feature. And they're like, oh, yeah, we're done. Are you done or are you done? Because those are two different things, right? Done and done. Done meaning integrated into mainline, tested, works in a production-like environment under realistic load. Don't normally test that on our workstations before we say we're done. And that's a big problem because that's where most of the pain and variability and complexity in our systems actually comes from, going from done to done. And so hopefully in your projects you have a burn-up chart or a burn-down chart or some other way of measuring the progress of your project. And it has a line for your scope. It has a line for starting development on a feature. Crucially, what you also need is a line for release to users. That's a really important line. Because if you're not measuring that, you're not actually measuring when you're done. And you're pushing off all the risk and pain to someone else. We'll worry about that later. Future devs will worry about actually making the system production ready. And these charts tell you at a glance two really nice and important things about your project. Number one, the vertical distance between red, which is starting dev, and green, which is done, that is the amount of batch size. That's the size of the batches that your features, basically, the amount of work you're doing at any one time, work in process. And then the horizontal distance between the red line and the green line, that's the lead time. The time between starting work on something and having it released to production. And what you really want to do to create an efficient delivery process is make this space as small as possible. That's how we create an efficient process for delivering software. So I was trying to think about what I was going to call the book that Dave and I had written. And I'm very bad at names. I was once in a band called the Chutney Ferrets. And I was kind of trying to consider names. And this year is the 10-year anniversary of the Agile Manifesto, and everyone knows that this over that, you know, working software over comprehensive documentation and all the rest of it. But there's also 10 principles in the Agile Manifesto, and the first principle is this. And upon seeing this, it became obvious what to call the book. And actually, Martin Fowler didn't want this principle in the Agile Manifesto. He said it's obvious, really obvious. Why do we need this? But it's quite easy to forget this. You know, in most organisations that are large, you have these silos between dev and test and ops, and everyone bitches about how terrible everyone else is at their job. And it's because we're measured in different ways. Ops is measured according to stability. Test is measured according to the number of bugs they find. Dev is measured according to throughput. How could that go wrong? Actually, we all have the same goal. And our goal is this. This is why all of us as software, as IT people, come into work every day. So I want to talk just very briefly about valuable software. The techniques that I'm going to talk about are expensive. You know, test automation, people working together, expensive. How do we increase the value of what we're doing? It turns out the biggest way we can improve the value of what we're doing is to do less. I talked earlier about those metrics about the number of projects we complete on scope, on time, on budget. Most of the time, we're not measuring actually the important thing, which is the amount of value we delivered to our organisation. What was the return on our investment building this stuff? The answer is it's pretty bad. This is based on a report by the Standish Group done on a set of Department of Defence code bases. This is a shockingly bad number. The biggest source of waste in the software delivery process is stuff that we build that's never used or rarely used. That's the biggest source of waste in software development. And that's why it's important to focus on the minimum viable products and iterating rapidly so we don't build stuff that's never used. And the incremental costs of doing test automation and deployment automation and all these things that I'm going to talk about, compared to this cost, it's tiny. It's minimal. So when someone says, well, this sounds expensive, this is the answer. Well, it's a lot less expensive than spending a year building something that nobody wants. So how do we achieve continuous delivery? I mean, hopefully by now I've made the case for it. How do we actually get there? Well, what we want to do is make sure that our software is always production ready all the way through its life cycle. That at any point we could walk into the room where the developers are working and press a button and release the latest good build to our users just by pressing a button. And we achieve that through this mechanism. Hopefully we're all using source code. But often we only keep... sorry, what am I talking about? Jesus, it's late. Hopefully we're all using version control. That's what I meant to say. Hopefully we're all using version control. Normally we only keep, or many of us only keep source code in version control. But actually, think about it. I can bring down a production system much more quickly by changing a configuration setting than I can by changing the source code. It takes ages to break a system by changing the source code. You have to build it, and then it has to go through testing, and then we have to deploy it. And then you find out if the backdoor you put in to steal all the company's money actually got through to production. But I can bring down a system just like that by changing a configuration setting. It's really, really easy. So why don't we test that? Why don't we test whether the configuration setting changes we're making, the database schema changes we're making, if that's going to break things as well? We should be. We should be testing everything. Everything required to build our systems from scratch, from nothing, from bare metal or MCVM, should be in version control. And that feedback, anytime you make a change to any of those things, the feedback on whether it changed the behavior of the system should go to everyone as fast as possible. And that's how you make sure your system's always production ready. So when you do this, your software is always production ready, hopefully. And also, a magical thing happens. Your releases and the work of the development organization is no longer the constraint in your organization. Suddenly, the speed at which you can come up with ideas becomes the constraint, because you're doing the minimum viable product and these tiny incremental additions, and you put it out there and you get some numbers based on what's happening in production. And then you can say to the business, well, look, we did this little thing and we got this change in our users' behavior. What should we do next? And they say, well, what about this? What's the smallest piece of work we can do to test this idea? Let's put that out. A few days' work, put that out, get some numbers back. What should we do next? IT is no longer the constraint. The business is the constraint. And people who do this, and there are large numbers of people doing this already, nobody wants to go back to the old way of doing things. Neither the business nor IT. Nobody wants to go back to the old way. So, how do we achieve continuous delivery? There's a few things. Firstly, automation. That should be no surprise, something that Chris talked about earlier. Secondly, there's a bunch of patterns and practices. And this is really what's changed over the last 10 years, because we were all talking about this, in the 90s and XP and all this kind of thing. But in the last 10 years, what's happened is tools and patterns and practices have emerged that allow us to automate everything. Database migrations and deployments, management of infrastructure. Puppet, a couple of days ago, released Windows support. So you can now use Puppet to manage all your Windows boxes in production. And thirdly, the other really important thing is collaboration between everyone involved in software delivery, not having these silos anymore. So how do we get started with this? Number one, configuration management. It should be possible for me to get a new box. If I want to add a new node to my production system and I'm not using the clouds, I should be able to get a box, put it into the rack, plug in the power, plug in the network, and have a fully automated process that Pixie boots it using Windows Deployment Services, installs the OS, installs any middleware I might need, configures that stuff, deploys the correct build to that box, configures it, and automatically configures the network and the firewall to start sending transactions, to start sending requests to that box, and has it processing transactions. That should be a fully automated process. As a developer, I should be able to get a new workstation, put it on my desk, plug in the power, plug in the network, and have a fully automated process whereby I can check from source control everything I need to build and test the system and type another command to deploy it to any environment I have access to. That's the level of configuration management we're aiming for. You don't need to have this to start off, obviously, because we'd never start anything then. But this is what we're aiming for, and this is entirely possible. Second thing we need is continuous integration, and I'll talk about that in a little more detail in a minute. And then the third thing is automated testing, testing at all levels. So who in this room uses continuous integration? Put your hands up. Keep your hands up. Keep them up. Keep them up. If everyone on your team does not integrate into mainline all their code at least once a day, put your hands down. If every change doesn't result in a build and test of the whole system, not a nightly build, but every time there's a check-in, put your hands down. Only the people with their hands up are doing continuous integration. Continuous integration is not using the source code management and build tools in TFS. It's a practice. And it's a practice that has rules. And I'm just going to briefly go through what continuous integration is as a practice to kind of justify what I said. So continuous integration looks like this. I make a change on my local workstation. Write a test, write some code that makes the test pass. I then run the build and run my unit tests and make sure that I haven't broken anything or done anything dumb. And because I'm really good, it goes green. Other people may have been checking in the meantime, and I want to make sure that my changes work together with their changes, and this is why the mainline bit is important. So I pull from mainline, and I merge the changes, and I run the build and the tests again to find out if the changes that I made conflict with anyone else's changes. And because I'm really good, it goes green. Yay! And at that point, I want to share my changes with everyone else. This is the point of source control. Source control is a communication mechanism, so you can share your changes with everyone else and get feedback rapidly on whether the changes you made kept the system working. So I push into mainline, and at that point, my build server picks up that change, runs the build, runs the tests, and because I'm really awesome and I should actually get quite a big pay rise, it goes green. Yay. The biggest thing for continuous integration, the number one rule is this. Everyone commits to the mainline at least once a day. Everyone pushes into mainline at least once a day. If you have code sitting on branches, by definition, you are not doing continuous integration. Integration means that your code is all merged into mainline. Otherwise, how do you validate whether the changes you made work with everyone else's stuff? Well, you can validate that it worked with mainline, but you can't validate that it worked with all the other people's changes that were being made. And guess what? The longer you keep that stuff out of mainline, and the larger the number of people on your team, the exponentially harder it gets to merge in when you need to. And that exponential thing is the crucial bit. That's why you need to be pushing into mainline every day, so you can prove that your changes keep the system working, and that you're not going to break everyone else's stuff when you do a refactoring and check it in 2 days later, and suddenly everyone else has to merge that refactoring with their last week's work, and it breaks everything, and suddenly everyone hates you. So, continuous integration. Everyone commits to the mainline at least once a day. I want to talk next about quality. And my favourite quote about quality comes from a guy called W. Edwards Deming, who's one of the founders of the Lean movement, very active in the Second World War in Japan. And he really founded the whole quality movement in Japan, one of the key players in that movement. And he has this to say about quality. Now, obviously, this is from manufacturing, but this has implications for software development. 2 important implications. Number 1, testing is not a phase to be performed after you are dev complete. Testing is something that we're doing all the time, that we should be doing all the time. That's how we build quality in. The cheapest way to fix a bug is not to check it into version control in the first place. That's why we have an automated build and unit test that we run before we check in. And then, if you do actually make a mistake and check your bug into source control, you don't want to wait for the testers to give you feedback. You want to have automated tests that validate that, that catch that bug as soon as possible. It's expensive to have a test to find a bug. It's even more expensive to let it get into production and find it that way, which is why, testing in production is something I actually agree with, but I think it's a horrible name, because it means people think, oh, you don't have to write automated tests, just test it in production. Woo! You want to test for bugs and find them all the time. The second implication of this is that quality is not the responsibility of the testers. Quality is the responsibility of everyone. Everyone on your team, developers, managers, operations people, everyone makes decisions all the time about quality. When you decide we're not going to do all these automated tests, it's too expensive, we want to ship features, that's a decision you're making about building quality into your process. When developers let the automated functional tests rot because it's too painful and expensive to make them pass the whole time, you're making a decision about quality. Everyone is responsible for quality. Testers serve a vital role in the software development process. They're the people who do crazy things and find the bugs that you would never ever find if you weren't a tester. Exploratory testing, usability testing, helping to create and maintain those suites of automated functional tests, that's what your testers should be doing. But they are not responsible for quality. They are responsible for making the quality of the system transparent, so you can then make decisions, business decisions, on what the quality of what you put out is. There's a nice analysis of the different kinds of testing you can do, which was made by a guy called Brian Marrick, one of the signatories of the Agile Manifesto, and he divides tests up into a quadrant diagram. He's a consultant, quadrant diagrams. And he divides tests up into whether they're technology-facing or business-facing, and whether they support programming or critique the product. So in the bottom left, we have the tests that developers write as they go along to make sure that what they're building isn't total rubbish. And that's the principles for doing unit testing are pretty well understood. I mean, not everyone's doing it. Who is doing unit testing, by the way? Tests that don't hit the database in the file system, that run very, very fast? Yes, okay, good. That's pretty well understood. Up on the top right here, these are the things that you can't automate and you shouldn't automate that your testers should be doing. My colleague Neil Ford has a joke. When humans do the things that computers could be doing instead, all the computers get together late at night and laugh at us. That's nowhere more true than having people doing regression testing. It's a massive waste of human talent to have humans doing regression testing, have these big manual scripts and people following them. People are really bad at following big stacks of instructions. That's why we have machines. So if you have humans doing regression testing, enormous source of waste, and it's expensive, and you can't move to continuous delivery because it's often the biggest constraint in your ability to deliver more frequently. So humans doing this stuff, computers doing this stuff, and then up in the top left we have functional acceptance tests, which are end-to-end tests testing user scenarios that are run in a production-like environment. And then in the bottom right here are all the ILITY tests. People call this non-functional testing, which I think is kind of a dumb name, because if your system crashes because it can't withstand load or someone nicks all your credit card details, the business tends to care about that. So non-functional testing is kind of a misnomer. I prefer cross-functional testing. But a lot of this stuff can be tested automatically. You can do penetration testing automatically, static analysis to find buffer overruns. Load testing can be done automatically. Not everything, but a lot of it can be done automatically. And you want to automate the hell out of all this stuff, really, so that your humans are doing this stuff up here, which is the high-value stuff that humans are actually good at and why we get paid money. What do we do once we have these tests? Well, we take continuous integration and we extend it out into production using a pattern called the deployment pipeline. What is the deployment pipeline? You have a process for going from check-in to release. Everyone's process is different. You have a process. Every time someone makes a change, that somehow works its way into production. You want to model that. And when you have a model of it, you should be able to see inventory in the form of builds created by changes that are checked into version control, move through that pipeline, move through that process, so that you have visibility into the production readiness of your systems all the time, so that you get fast feedback on the effects of the changes you make on the behavior of the system, and so everyone gets control over their work. Testers should not have to raise tickets or send emails to get a build that they can test. They should be able to press a button to deploy the build of their choice to their testing environment on demand, so they can do their work without having to talk to people. And the same with operations people. You should be able to deploy a build to staging or production in a push pattern way, any build of your choice. And that removes another big source of waste in the software development process. And so once you have all these things we're talking about, you can create a deployment pipeline. And it looks a bit like this. Someone makes a change to one of the elements that constitutes the production system: configuration, database, source codes, tests. And when you make a change, check it into version control, that triggers the build and the unit tests. And if those fail, everyone stops what they're doing, someone volunteers to fix the problem, everyone else gets back to work, and someone then fixes that. That's then the highest priority of the team. And that change to fix that problem makes the unit test pass. At this point, if the build and the unit test are successful, we want to trigger the automated acceptance tests. These will take a lot longer if they're any good. One of the products I work on, Mingle, we have a set of end-to-end Selenium tests that takes about 36 hours to run. We parallelize it massively on a big grid of 60 boxes and get feedback in about 45 minutes. 3,000 end-to-end Selenium acceptance tests. And if those fail, again, everyone stops what they're doing, someone volunteers to fix the problem, you fix that problem, you check in the change, and then those acceptance tests pass. At that point, an email goes to everyone who cares. Maybe the whole team, maybe just the testers, to say, here's a new good build. And if they want, they can deploy that build or any other build to their testing environment and start testing. When they're happy that that build is good, that it has the right fixes in, that the functionality that's required is working, they can then type that into the system, and then an email goes to the next people downstream of that, and they're able to deploy that build or any other build to their environments, and this goes all the way to production. So this is a kind of very simple linear example. Your process may be much more complex. There might be parallelism in it. But the point is you want to model your process all the way to production and have changes propagate instantly through it. The big deal with continuous delivery is every change I make results in a build. And every build is a release candidate. And what the pipeline is trying to do is kill the build. Prove that that build cannot be released, that the change that you made is too high risk. It's like every change results in a build, and every build is like a mythical hero from a Greek epic. And in order to marry the beautiful woman, the hero has to fight the horrible monster and go and collect the gold and go down into Hades and have an emotional reunion with his father. And then when the hero's succeeded in all these things, then he can marry the beautiful woman. Yay! And IT is a bit less romantic than that and a bit less exciting. Your build gets deployed to production, but it's still kind of cool. So this is what we're trying to do with the deployment pipeline. We create release candidates and we try and kill the release candidate, prove that it can't be released. And if a build passes all of these steps in the deployment pipeline, then we should have no compunction pressing the button and having that release into production. That should be a zero-fear operation. And if it's not, that means that the validations we put in place are not good enough, and we need to improve them and make them more severe. And we thus determined that our change was low risk, which is important for the ITIL heads who care about standard changes which are low risk. So in the deployment pipeline, there are a bunch of trade-offs. This is a slightly more complex process where you do UAT and performance testing in parallel. As builds progress through here, you have more confidence that you can deploy them to production. However, these things take time. And the reason we have a pipeline is so that we can get fast feedback in a few minutes, which is not comprehensive to the team on every change that's made. This is the continuous integration part. If we had infinite computing power, we'd run all the acceptance tests and the builds in infinitesimal time and get really rapid feedback. But we don't have that luxury, so you have the commit stage, which takes a few minutes, and then the acceptance test, which runs the rest, the acceptance test stage, which runs the rest of the automated test and takes a bit longer. And then, if builds pass that stage, then we can consider them for deploying to UAT environments, for performance testing, and so forth. And when you do that, you have something... this is a Microsoft conference. You can implement a deployment pipeline with TFS. It's possible to do that. It's still a bit clunky because it's not something that Microsoft has kind of committed to putting on its roadmap. I think they've talked about it. I don't know, to be honest. You can do it with TFS. However, I work for a company called ThoughtWorks Studios. This is my only product plug in this presentation. We have some software called Go, which allows you to do this, and it looks a bit like this. And the idea is that you can see every change that's made to version control up the left-hand side. You can click through and see what they're working on, checking comment, and the story that was being worked on. And you can see for each change how far that got towards production. You can see, this one failed the unit tests, and then we checked in a change to fix that problem, and that change resulted in a build that went all the way to production. and then someone made another change, and that didn't get all the way to production, didn't go to UAT, and you have these buttons that you can press that can deploy it to a particular environment. So this is what it would look like in a tool. When you're moving to continuous delivery, there's an important question to consider. And that question is this. Logging into your production box and editing files with Notepad does not count. You have to use your actual process for delivering. And this number is called the lead time of your process for delivering software. And what we want to do is optimize our process for delivering software for lead time. That's what we're trying to do. We're trying to optimize for lead time. I've just realized the equation that I want to show you isn't in this presentation. So I'm just quickly going to switch to another one. Or am I? Okay. Just give me a sec here. When we optimize our process for lead time, an interesting thing happens. This is an equation in a book which is my favorite book of last year. Fantastic book by a guy called Don Reinertsen called The Principles of Product Development Flow. Fantastic book. And he derives basically how to do product management right using maths and techniques from warfare and operating system design and queuing theory and a number of other kind of scientific areas of endeavor. And this equation is derived from queuing theory. Queuing theory deals with things like the behavior of airline check-in desks and the behavior of cars on freeways and things like that. It's a very general, powerful paradigm for looking at how you process transactions and the behavior of queues that form behind transaction processing systems. And this equation relates the amount of time you're doing something useful. The particular application we're talking about is a software delivery process. As IT dudes, we're building functionality, right? So what's the behavior of our system to build functionality? Well, this is the amount of time we're doing useful stuff. We want to make this side of the equation go towards 1. We want to make this as near as 1 to possible. That's what optimizing for lead time looks like. On the right-hand side of the equation, there's this symbol, which is a Greek symbol rho, and that stands for utilization, the amount of utilization of the resources in our system. Now, if we want to make the left-hand side of this equation go to 1, what we want to do is make the right-hand side of this equation go to 1, which means that we want to make rho go towards 0. If we want to optimize for actually delivering software as fast and efficiently as we possibly can, we need the people in our teams to not be utilized at all. And that kind of makes sense if you think about it. If you're checking in for a flight and there's a check-in desks and the check-in desks are busy all the time, and there's a big queue of people, it's going to take you a long time to check in. If there's a massive row of check-in desks, you're going to be able to get checked in pretty quickly to your flight. And it's the same with software. If everyone on your team is busy the whole time, if a new requirement comes in, it's going to take a long time for that requirement actually to get built and go out the other end. And this is a problem because many project managers optimize for utilization. They want everyone on their team to be busy. Why aren't you busy? Why aren't you doing anything? This comes from the cost accounting model in software development. And that's a really bad thing. When people say, well, why isn't your velocity high enough? We had this velocity last week, we want this velocity this week as well. What you've done is you've optimized your system for utilization, and you have thus created the most inefficient process that you possibly can for delivering software. Optimizing for utilization creates the most inefficient process you can possibly design for delivering software. It's a big mistake that people make. I'm just going to pop back to the other presentation here. So I'm kind of running short of time. I have a bunch of patterns on reducing release risk. A lot of them were talked about earlier, the idea of blue-green deployments, canary releases, and so forth. Those are all available on the web Martin Fowler's site and my site, continuousdelivery.com. I just want to say something briefly about reducing release risk, because the whole point of continuous delivery, or well, for operations people and IT people, one of the main points is trying to reduce the risk of release. How do we do that? Firstly, automating provisioning and deployment, as we discussed earlier. And secondly, ensuring that developers and testers and operations and all the people involved in software delivery collaborate throughout the process. And there's two key learnings about delivering software in a low-risk way, releasing to users in a low-risk way. Number one is that low-risk releases are incremental. You don't want to deploy your whole system in one big bang. If you have a complex system, what you want to do is split the deployment into as many pieces as you can. If you have static content, don't overwrite the old static content with a new static content. Have it side by side in a new folder. If you have new services that your system depends on, don't overwrite the old services. Deploy the new services side by side. When Amazon Web Services releases a new version, they don't overwrite the old version. If you look at the URI, it's /year/month/date/endpoint. And you can still access the old API for EC2, because obviously, Amazon doesn't want to break all their existing customers when they release a new version of their API. It's all side by side. You can do the same thing with databases. Flickr does not release database changes 10 times a day. They do it about once a week. And it's the same with Facebook. Facebook are putting out changes every day, but they're not doing database changes every day. They're doing it about, well, they don't actually tell you how often they're doing it. That information isn't publicly available, but it's not once a day. What they do is they only ever add new objects to their database. New columns, new tables. They don't change existing columns. They add new columns and copy data over if necessary. So when they put out a new release that depends on a new object in the database, they create the new objects in the database first, and then they release the new version of the software that depends on those new objects. And if they want to roll it back, they can roll back the software, and that's fine, because it's still compatible with the new version of the database. So they decouple database changes from application changes, so you can do them independently. Decoupling your deployments into multiple steps that you can put out incrementally is a really important way to reduce the risk of release. And you can do the same thing with your application using the blue-green deployments technique that Mark talked about earlier in his talk. So we're running out of time. I'm going to skip over that stuff. The other thing that I wanted to say is that the other technique for reducing the risk of releases is to decouple release from deployment. They're two separate activities. Release is making features visible to users. Deployment is putting the software into production. Two separate things. There's a great video on TechCrunch by the release manager from Facebook, and he says every major feature in Facebook that will be released in the next 60 days is already in production. You just can't see it yet. And they use feature toggles to control who can see which features, and a bit of software called Gatekeeper. So for any particular feature, they can say only people inside Facebook can see this, or only women under 25 in France can see it, or only people who aren't members of TechCrunch can see it. They actually have a toggle for that. So decoupling release from deployment, a very important way to reduce the risk of release. And that's also, by the way, all of you who are doing feature branching and you're worried about, well, we need to release more frequently, but our features take 2 weeks to develop. How do we check into mainline? Well, apart from making your stories much smaller and checking in much more regularly, the other way to do that is to put feature toggles in so that you can switch features off while they're under development until they're ready to be shown to users, but still carry on checking that code into mainline and potentially deploying it into production. The final thing I want to say really is that it all ultimately comes back to people. All problems moving to continuous delivery ultimately come down to people problems. And it's important, anytime you start some new product, get everyone together, the operations people, the developers, the testers, the management, before you start writing the requirements document, so that you can decide on the minimum viable product and start building that. And then keep meeting all the time. You have, hopefully, who has retrospectives that they perform every iteration? Okay, many of you, but not all of you. The retrospective is, in my mind, the key agile process, because the retrospective is the engine of continuous improvement. It's how you make things better. You know, when I said that you don't want to optimize for utilization, what happens with all those people who aren't busy? Those are the people who are improving the process, who are automating the build and the deployment, who are automating the tests, who are doing all those incidental things that oil the delivery machine and keep it working all the time and make sure you can actually deliver valuable, high-quality software quickly. You need slack in your system, and the slack is how your continuous improvement happens. And continuous improvement happens according to the scientific method. I have a hypothesis. I can change my process for my team and make it better in some way, I think. I'm going to run an experiment in the next iteration to try this process change and make things more efficient. And then in my retrospective, I look back and I see, did that experiment work? If it worked, carry on doing it. If it didn't work, try something else. The ability of teams to change their process and the ability for them to run those process changes using the scientific method, using retrospectives as the heartbeat of that process, is the key to agile adoption. It's the way that it can be made to work. So have everyone keep meeting, retrospectives, showcases, and so forth. Have those graphs that show your deployment pipeline, those stats in production. Have those graphs and pictures everywhere throughout your organization. LCD screens are really, really cheap. That information should be available to everyone so that everyone can get feedback. Continuous delivery is all about creating feedback loops and optimizing your feedback loops and getting really rich feedback all the time. And you're never done with continuous delivery. Continuous delivery is not something that, everyone stops what they're doing and we're going to go continuous delivery and suddenly after 2 weeks everyone's doing continuous delivery. No, it doesn't work like that. Continuous delivery is about continually improving your process, continually doing things a little bit better. Find out what the constraint is in your process right now. What's the thing that's holding you back, that's preventing you from delivering high-value, high-quality software? Find that biggest constraint and do something small to make that a little bit better and just keep doing that. That's how you implement continuous delivery. And that's pretty much it. We have another 3 or 4 minutes for questions. What questions do you have? Yes?
Minimizing release risk by small incremental deployments sounds great. But have you ever had to try to deal with that when you had a complete system conversion from the old system to the new one? Not the incremental improvement.
So that's a great question. If you're replacing an existing system, how can you do that incrementally? The worst possible way to do that is start up a 2-year project to replace the entire system using the existing requirements document in a big bang release. Okay, that's the worst possible way to do it, and unfortunately it's the way that most people do it. There's a great pattern called the Strangler app pattern, and Martin Fowler has blogged about this, and the idea is, what's the thing in the existing application that's most painful and that most needs to change? Write a new system using a new code base that just does that one thing better and get the requirements for that new thing and build that. And integrate with the existing system, but you just create a new page just to do that one thing. And you run it all side by side. And so you replace the existing system incrementally. And because the problem is, it turns out that 5 years after the existing system was built, hopefully your requirements have changed somewhat. So you want to discover what the new requirements are and prioritize the building of the new system according to business priority and replace it incrementally. That can be painful, but it's by far the best way to do it. You're welcome. Yes.
Like a service point of view where like you mentioned, you have the old service and then you deploy a new service. What about a web application where you can't necessarily have, I suppose you could, but you try to deploy that web application out there and then have certain features toggled off and make sure that QA is okay with that in terms of testing so that they don't say, well, we have to test everything because you replaced it.
Right, so the question is, feature toggling, what's the methodology for testing when you're doing feature toggling? Well, the key thing is, when you're doing feature toggling, you're checking in code, but that code has no path. That code path isn't used in production, right? Because the ability to actually execute that code path is switched off. So what you need to do, crucially, is you need to be writing automated acceptance tests that test that code path as you check in before you deploy. So that new code you've written, that code path is tested using automated acceptance tests, and those work. And then what you do, obviously, if you're running acceptance tests, you end up with a combinatorial explosion of every possible feature toggle on or off. So you don't want to run that. What you do is you run the acceptance tests in a batch with all the feature toggles in their current production state. And then you run the tests a second time with the feature toggles in the state that you want to release the next version at. And that's how you do the acceptance testing, the automated acceptance testing with feature toggles. You have 2 runs, one with the toggles on and one with the toggles off. And then, crucially, you go and clean up after yourself and remove the old feature toggles. Guy with the hat.
Your system with the 3000 Selenium test, whatever.
Yeah.
You got cross-functional teams. Who's writing the tests? Who's maintaining those tests?
Excellent question. 3000 Selenium tests, who writes them, who maintains them? I have pretty strong views on this. Those are built by cross-functional teams where the testers and the developers sit together. And what should happen is you have a requirement. As part of a story, you have acceptance criteria that tell you when you're done with the story. And the testers and the analyst or the customer or the business work together to decide what those acceptance criteria are. And then you write automated acceptance tests using those acceptance criteria. And the whole point of FIT and these tools is that the acceptance criteria are executable. You have executable specifications. And when those executable specifications all go green, you're done with the story.